let's add fractions. When you add fractions, you need a common denominator, right? Let's get a common denominator. Don't make this harder than it is. I need to know what number 2 and 3 both go into, okay? So not what goes into them, what do they go into? What's the smallest thing? This is the least common denominator, also known as the least common multiple in other contexts. What is the smallest thing that 2 and 3 both go into? 6. So turn every fraction into a fraction that has a denominator of 6. So then you ask yourself, okay, how am I going to do that? What did I do to change a 2 into a 6? I tripled it. Let me get back in frame here. I tripled it. So 2 times 3 gave me 6. So 1 times 3 is going to give me 3 in the numerator. Leave this step off if you want to. Jump to the next one if you like. 3 times what gives me 6? Oh, 2. So I have 4 times 2. So the next step, which, you know, you could jump straight there, is 3 over 6 plus 8 over 6. And I know you're like, I've seen this before. I know what I'm doing. I hear you. It's going to get more complicated with variables, so that's why we're doing this now. If you're looking at that and you're saying, oh, 3 over 6 is a half. Yep, absolutely. That's where it started. Don't go backwards. What I do have is 11 over 6. Done. It doesn't reduce anymore. If it does, I will. All right, let's go to the next problem where there you are. Least common denominator is not as obvious, and we're going to have to figure out what that is. So our least common denominator among 12 and 15. So what does 12 go into that 15 also goes into? Okay, here's a strategy that I have. I like to take the big number and start listing, at least in your head, listing the multiples of that. 15. Does 12 go into 15? Nah. 30. That's another 15 added. That's 15 times 2. Does 12 go into 30? Nah. All right, add another 15. Does 12 go into 45? Nah. We're going to be here all day. Add another 15. Does 12 go into 60? Yeah. There's your least common denominator. 60. Change both denominators into a 60. Okay, so 12 times what is 60? 5. So you need 7 times 5. Yes, it's 35. Skip this step if you like. 15 times what is 60? It's 4. Okay, so 2 times 4 goes there. Yes, it's 8. Skip that step if you like. We're going to have 35 over 60, which reduces to 7 over 12, but don't reduce it because you'd be working backwards. And we're going to subtract 8 over 60, and then we're going to just subtract. So 35 minus 8 is going to over 60. 35 over 60 minus 8 over 60, I should say. That is definitely over 60, and that is 27 over 60. Okay, does this reduce? Yes, it does. It does. So what we're going to do is reduce this. I would bring it down, but I've brought this thing down far enough. Let's just keep moving it over this direction. Doesn't matter which direction you take your work. I'm going to reduce this. Let's see, 3 goes into that 20 times. 3 goes into that 9 times, and I'm left with 9 over 20. Does that reduce? No, it doesn't. So we're done. Okay? Let's go to the next one, which is lurking over here in the corner, like they all are. You never know when there's another problem hanging around over there. What we're going to do is find the least common denominator among x and 3. Now, a minute ago I said take the big one and then keep writing multiples of it. And I'm going to do that, but let's pretend for a second that x is the big one among these. So x, does 3 go into x? No. All right, then another x. That'd be 2x. Does 3 go into 2x? No. All right. Does 3 go into 3x? Definitely. Now, we don't know what x is, and we'll never know from this problem because we're asked to simplify, not solve. Otherwise, the final answer would say x equals whatever, and we don't have enough information for that. But what I can do is say, well, I have x, and then 2x, and 3x. Oh, well, 3 goes into 3x for sure, regardless of what x is. So 3x is my least common denominator. Now, the other way of doing it is saying, oh, x times 3. Yeah, that works. Let's back up for a second, though. Back way up. You're going to do 12 times 15 to get your least common denominator. It'll be a common denominator, but it won't be your least common denominator. And then you're going to have a massive fraction down here to reduce. It'll work, but it's going to be a pain. So it's not worth it. Okay, like sliding these things, not worth it. 3x, 3x. Okay, so now things get a little bit tricky. How do I turn an x into a 3x? Like, what would I do? well, I'd triple it. Okay, so then 4 times 3. Now, if you want to get technical, you could say, I could cancel this 3 with this 3, and I have 4 over x. You sure would, but again, you'd be working backwards. Please don't do that. Not worth it. 3 turns into 3x by multiplying by x, so then I have 1x. Okay? All right, so I have 12 over 3x. Don't reduce it. And I have x over 3x. Don't reduce it. And that's going to give me, well, let's add fractions. Keep your denominators and add the numerators. That's what we've been doing all along. From the very beginning, you add the numerators, keep the denominators, or subtract if that's what you're supposed to do. There we go. Those are the first basic problems. They're going to get a little more complicated and more fun.